Hey guys, so in this video, I'll show you how we run the wind tunnel experiments and get data for our project. Before running the test though, I first need to figure out the relationship between the fan RPM and the free stream velocity in the tunnel. Now remember, this is an open circuit wind tunnel, so the setting could be slightly different each time that we do the tests. So what I'm doing right now is putting together the pitot tube that will help us measure the free stream velocity directly. As you can see, the pitot tube connects to a digital airflow meter, where the blue hose connects the total pressure and the red hose connects the static pressure. Okay, so once that's ready, we pop off this cap on top of our wind tunnel and replace it with this 3D printed one with a hole that we're going to put the pitot tube through. Now I'm just making sure that it's straight and in the middle. And we're ready to run the wind tunnel. JK, I need to take my phone out first. Because now we flip on the power switch. Flow meter is 0. Power on. And we turn this knob to control the RPM, which is the number on the top. Let's check our flow meter now. Okay, so we want 20 meters per second, so let's tune this knob until we get it. Alright, that seems pretty good. 1279 RPM for today's test. And our pitot tube looking all good here. So now we open up a software called LabVIEW, which helps us collect data. Basically, you can program your own data collecting interface, and I'm opening up a pre-made file for our load cell. What I'm doing now is loading up the calibration file for our load cell, which will help us convert the voltage signals to forces and moments. Now, I forgot to show you earlier of me connecting the load cell cable to this PXI module, but basically the signal goes from the load cell to the PXI module and then to the computer onto LabVIEW. And you see here that we will be collecting 1,000 samples at a rate of 10,000 Hertz for each test. Okay, so now I let it run, and immediately you see some readings. Here we got the 3 forces and 3 moments. The loads we see now are the preloads on the load cell, like from the weight of the assembly, the torque on the bolts, things like that. But we don't want all that, so we click bias and voila, everything goes to 0. Unbiased, biased. Set the destination for saving the data. And we're ready. Okay, looks pretty stable. And let's collect 1,000 samples by flipping this virtual switch. Turn down the fan to 0. Unclamp. Change the angle and repeat. That's it, guys. You just need to do this for all the different angles for each airfoil and we get all our data. So if we load up our data from the first angle that we tested here on Excel, you see 6 columns, which are for the 3 forces and 3 moments, and 1,000 rows for the samples that we took. We can simply average each column to get the average lift force and average drag force from those 1,000 samples. And I already did this for all the test data files for your project, which you can find as a spreadsheet on Canvas.